Hello and welcome to my web application series part 2. In part 1, we'll look at the project diagram and create an HTTP server, router, and some placeholder for the endpoints. In this video, we are going to create our first handler, which is the homepage, and begin working on user authentication. So far, we only use the get method for our endpoints to render web pages. However, we need to create post, patch, and delete methods to handle the logic of the endpoints. For the logout, we don't need any additional method because logout doesn't render any web page and acts purely as logic here. So we are going to keep it as it is. For updating a product, we need to use the patch method as recommended by the HTTP protocol. Additionally, we are going to use the delete method for deleting a product. You may be wondering what is the ID inside the curly brackets means. This is considered a URL parameter that can be retrieved in the handler and utilized. Now we need to create some directories for handlers. You can design your directory structure as you prefer. For standalone projects, I usually create an internal directory that is isolated from calls by external packages. For the homepage handler, I can simply place it in the app directory as it is purely a web page renderer for now. We will begin by creating the Go file for the homepage handler in the app directory. As mentioned earlier, the homepage is simply a web page renderer and doesn't require any controller or logic. Therefore, I'm going to name the handler homepage. In the handler function, we need to have two parameters: a response writer, which will write data into the response along with the handler status, etc., and the request, which holds the request data issued by the client. For demonstration purpose, I'm writing an HTML tag directly into the output. Now that we have created our homepage handler, we need to call it in the handle func instead of the placeholder. First, I'm going to use CURL to check the output. The output should be as expected. If we go to localhost, we should see our simple HTML tag rendered in the browser. Now that we know how to create handlers, let's create one for user registration. Because registration involves two parts, the web page and the logic, we need to create both page.go and controller.go files in the register directory. For the web page handler, we will name it page and use the same handler func parameters for this function. This handler is responsible only for rendering the web page. For now, I will write an HTML tag directly into the output. We will also create the controller handler with the same function signature as the page handler. Now we can replace the placeholder with the handler and try to render the page on the browser by going to /out/register. We will do the same for the controller handler. However, this time we will use CURL to see the output as the controller doesn't render any web page. The CURL command has a new parameter to specify the request method, which is post, and we can see the result is as expected. To render the HTML page, we need to start by creating an HTML template. First, we need to make a directory for the HTML files. In Go, we don't need to specify any file extension for the HTML files to work. The HTML template package only cares about the content of the files. However, for better understanding, we can add the extension. Now we can write an HTML file, and I'm going to keep it simple for now. Back to the page handler. First, we create a slice for the pages that we want to render and add the file path to it. I will show you why we need to render more than one page in future videos. To render the template, we need to use the HTML template package. The mask function ensures that the template is correctly parsed and is not nil. Using new function allows us to create a new template with the name of the HTML file we created earlier. To complete the process, we need to use the parse files method and pass the pages slice to it. Next, we need to execute the template using the execute method. For the data parameter, we set it to nil for now. If there is an error, the mask function will panic, helping us identify the problem. There are two things that I left here on purpose to demonstrate possible errors when rendering a page. First, when we're setting the page for the HTML file, we need to start with the top level directory of the project, which is internal. Second, the name of the template must be identical to the file name. Now when we refresh the page, we can see that the web page has been rendered correctly. We have already rendered an HTML page, and now it's time to create a registration form for our users. The registration form will have email and password fields, along with a register button to submit the form. To make this form send data to our post endpoint, we need to specify the method. In the register controller, we first need to accept inputs. To do this, I'm going to create a register type named reg with 2 string fields. Then I'm going to create a variable of a reg type and assign values using the postFormValue method from the request. The postFormValue method retrieves form data, and we just need to pass the HTML input name as its parameter value. In this case, there will be email and password. Now we can test whether we get the value on the backend side or not. And we see that the result is as expected. Like any proper backend application, we need to have form validation. First, we're going to validate the email address. In the same directory, I'm going to create the email validation Go file. The email validation function requires only one parameter, which is the email string, and as the output, we use a boolean. In a very basic email validation, we should check for the @ ensure it is not empty and has a dot. To check for the @ we can use the count function from the string package. This function will take the email address and look for the given character in the second parameter. If no @ is found, we will return false as an invalid email address. Since we found the @ we can split the email address into address and domain. If either of these is an empty string, we will return false. After checking the @, address, and domain, we can check if there is a dot character in the address or not. At the end, we return true. Now, we need to work on the password validation. I will create a Go file in the same directory for now, naming it passvalidation.go. We can name the function isPasswordValid with 2 parameters, pass with the string type and length with integer type. And for the output, we will use boolean. The first thing we need to check is the length of the password. If it's less than a certain number of characters, we are going to reject it. Next, we need to have some rules for our password. Any good password requires at least a lowercase, uppercase, and numeric character. To keep it simple, we won't include special characters. To check every single character, we're going to use a for loop to get the character's ASCII number. So to check this, we need to take a look at the ASCII table. On this table, you'll find a sequential numbers that represent a character. For example, the lowercase character A is 97 and the lowercase z is 122. The same goes for uppercase A and uppercase Z. We can also find the numeric characters from number 48 to number 57. So we can use these numbers to easily validate the password characters. To check the rules in the loop, we are going to use a switch statement. Since we get the ASCII numbers from the char variable from the loop, we can simply check the number by passing the characters A and Z with the single quote. We are going to do the same thing with the uppercase and numeric characters. If you prefer more restriction, you can add special characters to your rule. At the end, we can use logical AND operator to make sure all the rules are valid. Finally, we can use this function to validate the password. Now we can test it all together. As you can see, the validation is working as we expected. That's all for this video, and I will see you in the next one. As always, thanks for watching.